The Boom team's been working extremely hard over the past couple years to design and build XB-1. We won't know if the aircraft performs to expectations until we actually fly it. The role of the flight test team is to take XB-1 supersonic as safely as we possibly can. We've got a number of tools to do that. One is a build-up approach, where we take what we've learned from the previous flight and plan the next flight using that information. We'll start with a small, well-understood part of the envelope and build from there. Another tool that we have is the simulator behind me. The simulator takes the latest information about XB-1 and gives the pilot a preview of how the aircraft's going to handle in flight. But it's not just the pilots that are going to make XB-1 safe. We're supported by a team of maintainers and flight test engineers. We'll include them in the rehearsals by linking the simulator to the control room. Any pilot will tell you that a simulator can only represent the real world so well. In order to get a real world flavor prior to first flight, definitely I will fly high performance aircraft like the F-5 and F-104. While not a perfect simulation, they'll let us hone our skills prior to the first flight.
The simulator has two primary purposes. The first is that of an engineering design tool, and the second is that of a training tool for both the pilots and the control room. We built this simulator here in order to test and get an early preview of the displays, the switch layout, the flight controls, and the view the pilot has out of the nose of the aircraft. This is version 2 of the simulator for Boom. This is the highest fidelity version of the cockpit outside of XB-1 itself. That allows us to run full rehearsals with the entire control room and get a true feel for how the entire envelope expansion will go for XB-1 throughout its entire envelope.
As the chief flight test engineer, I'm responsible for keeping Doc and Duff safe in the aircraft by leading the control room team on the ground. Just like you've seen on NASA spaceflight missions, we have a control room to help ensure the safety of our aircraft. The difference is the engineers in our control room are the same ones who designed and built the aircraft, so they know it like the back of their hand. I'm currently taking our team of 30 engineers through a comprehensive training and rehearsal program. The objective of this is to make sure that they're prepared for safe flight tests and everything happens efficiently. By the time we get done with the training program, they'll have probably seen the first flight over 100 times. During the training program, I'll give them different scenarios where they'll have to respond to a problem and come up with a solution. As an example, I may increase the temperature on a flight critical component of the aircraft beyond its maximum value. They'll have to figure out how to safely recover the aircraft. By the time we're done, the engineers should be ready for just about anything, ensuring that we have a safe first flight that goes exactly as planned.
One of the reasons that we train so much is that XB-1, like any supersonic aircraft, has some unique handling qualities. In order to be efficient at high speed, XB-1 has a narrow wingspan. And one consequence of this is that on the approach to the runway, XB-1 is pretty fast and it has a pretty high angle of attack, meaning that the nose is well above the horizon. This can make it difficult for the pilots to see the runway. The way Concorde managed this challenge was to mechanically droop the nose to give the pilots a direct view of the runway. For XB-1, we have 2 cameras mounted on the nose gear. These give the pilot a virtual view of the runway. The advantage is that they get all the cues that you'd get from the direct view, but without the mechanical complexity.
Throughout the entire program, the role of the test pilot is that of the skeptic. It's our job to constantly challenge and question every engineering design decision in order to ensure we have the safest aircraft possible by the time we enter flight. As we enter engine runs and taxi tests, however, we'll start to trust the aircraft and believe that it's truly safe to go fly. At this point, that crucial role of the skeptic must be filled by someone else. We will purposely transition that role to that of the chase pilot, the other test pilot in the program that will be airborne with us on every single mission. They will help us safely execute the entire envelope expansion.
When it comes to decision making, our varied flight test experiences and backgrounds is one of our strongest assets. Between the 3 of us, we've attended 2 different test pilot schools, we're in 2 different branches of the military, and we've flown everything from helicopters to high-performance aircraft. When we have to make a decision, we'll sometimes approach it from different perspectives, but always with the same fundamental mindset of maximizing safety and minimizing risk to the program. It'll all come together in the desert over Mojave in the very near future. The first flight of XB-1 will be a historic event, just like the historic first flight of the Bell X-1 many years prior. We're looking forward to accomplishing that milestone and can't wait to share it with all of you in the next year.